Welcome to solving quadratic equations by factoring. All right, so determining x-intercepts. When you graph a quadratic equation, you get a parabola. And the solutions to the quadratic equation represent where the parabola crosses the x-axis. When we factor a quadratic equation, we're looking to find the two binomials that were multiplied to create the trinomial part of the quadratic equation. When we solve a quadratic equation, we are looking for x-intercepts. And you have this bottom part in your notes. You have that sentence and this part here. So to find the x-intercepts, think about the value of y on the x-axis. Since y equals 0 at the x-axis, we set each quadratic equation equal to 0. Then we factor and solve by setting each factor equal to 0. So if we think about our dolphins here, right, what's the height of the dolphin when he leaves the water? Right? His height is 0. When he returns to the water, his height is 0 feet again. Right? So we're going to be setting our equation equal to 0, and then once we factor, we'll set our factors equal to 0. Other than that, our steps are going to be the same. Right? So this is also in your notes, zero product theorem. So if a and b are numbers, and a times b is equal to 0, well, the only way that would be true is if either a is 0 or b is 0. When you multiply two numbers together, you only get 0 as an answer if one of those numbers you're multiplying is 0. All right, so how does that apply to our quadratics? All right, so if we have x minus 4 times x plus 3 is equal to 0, the only way that would be true is if x minus 4 equals 0 or x plus 3 equals 0. So if we set those equal to 0, we have x equals 4. Right, we add 4 to both sides. And we have x equals negative 3 to that equation that's already been factored by substituting into the original equation. Right? So the original equation was x minus 4 times x plus 3 equals 0. By the way, I could check them in the factored form. You don't actually have to check them in the unfactored form in the original equation. But I thought I would give us our original equation again. All right, so when we multiply, we'll have x times x, or x squared. We'll have 3 times x, or 3x. Those inner terms, negative 4 times x would be negative 4x, and negative 4 times 3 would give us negative 12. All right, so now we combine the like terms. All right, so 3x minus 4x would be a negative x. And so now if I plugged in a 4 into that equation, I have 4 squared minus 4 minus 12 equals 0. Well, 4 squared is 16, and 16 minus 4 would give me 12, and 12 minus 12 is 0. So 0 equals 0. That one checks out. And the same thing with the negative 3. Negative 3 squared is 9. Minus a negative 3 would be a plus 3, and then minus 12. Well, 9 plus 3 is 12, and 12 minus 12 is 0. So 0 equals 0 checks out again. So if you're never not sure, you can always plug it back into the original equation. All right, so here are the steps for solving a quadratic equation by factoring. Okay? First of all, we're going to write the equation in the form ax squared plus bx plus c equals 0. So we have to make sure that everything is on one side. We're going to factor the equation completely. Sometimes you can use greatest common factor. Sometimes you'll use factor by grouping. And sometimes you use a little of both. Right? We'll plot the greatest common factor, and then we'll factor by grouping for the rest. You'll apply the zero product rule. You'll set each factor equal to 0 and solve. And solve the resulting equations. And to check the solutions, and this is an optional step, to check the solutions found in step 3, all you have to do is substitute in the original equation. All right, so to solve a quadratic equation, factor as usual, right, then set the factors equal to 0. When we solve a quadratic equation, we're finding the x-intercepts, and y is 0 on the x-axis. And so I don't think all of the steps here. Actually, I do have, no, I don't have all the steps in your notes, I don't believe. I think I actually kind of put it on the next page, really, really tiny small, right? But you can also, write these down. You can pause the tape and write these down if it helps you, to help you remember. All right, let's continue. Let's do a problem together. And we have 6x squared minus 7x plus 2 equals 0. All right? And this one is in your notes, right? So we are going to go through the steps several times. And the first one is in your notes. So our first step is we want to factor. We've got everything on one side, just like we need it, right? We've got the squared term first, and then we've got the x term, and then we've got our constant, and it's equal to 0, right? So we want to, this is what's called standard form. You want to make sure that it's in standard form first, right? But it is. All right, so now, just like before, right? A is 6, and B is -7, and C is 2. We multiply A times C, right? So 6 times 2 gives us 12. We need two numbers that multiply to give us 12, but add to give us our B term of -7. So this 12 here is just what A times C was, and the -7 is what B is. All right, so two numbers that multiply to give us A times C, and multiply to give us 12 and add to give us -7, well, that would be -3 and -4. So we're going to replace that -7x with a -3x and a -4x. I believe your notes at one point had an error in it. I believe I fixed that to a 2 is what it should be, and yeah, I did. It's in red for me because it was an error on your notes. All right, so now the first two become a group, and the second two become a group. And then we're going to pull out the greatest common factor. Well, 6 and -3 are both divisible by 3. And we've got x squared and x. So they're both divisible by x. So the greatest common factor for 6x squared and -3x would be 3x. 6x squared divided by 3x would be 2x. And -3x divided by 3x would be a -1. All right, so greatest common factor for -4x and 2 is going to be the 2. Right? -4x divided by 2 is going to be, a -2, a -2. Right? 'Cause I don't want that negative. I don't want that term there to be negative, right? It's got to be positive, right? It's got to be a positive 2x. So we have to divide by a -2. Right, so -4x divided by -2 would be a positive 2x. And then 2 divided by -2 is going to be a -1. Right, so now we see we have a matching 2x minus 1. We have to have that common binomial that's got to match. Right, so that's one of our factors, is the 2x minus 1. What we pulled out, 3x minus 2, is the other factor. So this is just like we did before, nothing different. We have one more step, and that step is to just set our factors equal to 0 and solve. All right, so we're using the zero product rule. So we have 2x minus 1 equals 0. All right, so I would add 1 to both sides. 2x is equal to 1, and then divide by 2. X is equal to 1/2. That's one of our solutions. And then our second solution, we're just going to set 3x minus 2 equal to 0. All right, so we'd add 2 to both sides. I'm stuck next to this extended page here. So we'd have 3x is equal to 2, and then we divide both sides by 3. So x would be equal to 2/3. All right, so we have two solutions. Our two solutions are x equals 1/2. That looks weird. Whoop, go away. X equals 1/2, and x equals 2/3. And that's all there is to it. All right, so just like before with the factoring, then we're just going to set the factors equal to 0 and solve. All right, and we'll do that anytime it's an equation. All right, let's do one more. I don't want to make this podcast too long, so I'm going to divide this into more than one podcast. All right, so I don't think this one is in your notes. I might be missing a page of notes when I went to grab them. So you'll just have to follow along and see if it's in your notes. All right, x squared plus 13x minus 48 equals 0. Right, so we've got it in standard form. Right, we have the x squared term and then we have the x, and then we have the constant equal to 0. All right, so our a is 1, our b is 13, and the c is negative 48. So we're going to multiply a times c together and figure out what two numbers give us that product, but give us a sum that's equal to b. So we need two numbers that multiply to give us negative 48, but add to give us 13. So those two numbers that are going to multiply to give us 48, and so it's going to be a factor of 48. So for instance, 1 and 48, or 2 and 24. Notice none of them are 13 apart. If they have a negative product, one of them is negative. So the numbers have to be 13 apart. I mean, those numbers aren't 13 apart. But 3 and 16, well, they're 13 apart. And those are our two numbers. And since it's a positive 13, that means that 16 is the positive one and 3 is the negative one. So 16 times negative 3 is negative 48. 16 plus negative 3 gives us 13. We replace the 13x with a 16x and a negative 3. And the first two become a group and the second two become a group. By the way, you could have switched those and made it a negative 3x and a 16. You could switch those numbers. The ordering doesn't matter on the two terms in the middle. You get the same thing no matter what. So greatest common factor for x squared and 16x, that's just going to be an x. So we'll be left with an x plus 16. Greatest common factor for negative 3x minus 48 will be a negative 3. Right, so negative 3x divided by negative 3 is an x, and negative 48 divided by negative 3 is a positive 16. So that repeating x plus 16, make sure it matches, is one factor. And what we pulled out, x minus 3 is the other. And this is a pretty easy solve. We're just going to set x plus 16 equal to 0 and x minus 3 equal to 0. So you'd subtract 16, x is equal to negative 16, and our second solution, add 3 to both sides, x is equal to 3. And that's all there is to this one, 2 down. All right, so now the next one here, that one is not in standard form. So I'm going to do that on the next podcast. I'll say goodbye for now and see you in the next podcast. Bye for now.